Hi guys, my name is Blaise and this is my submission for the extra credit video. And I'm going to solve this following circuit right here. Use a circuit shown below to solve. The circuit is in steady state. Find a numerical expression for VA as a function of time. So for phasor domain problem, you should always convert all your components, all your voltage source, all your current source into phasor domain first. So we can see right here, IB is 2.4 amps, and with the angles is 112. Since it's a cosine, that means the angle stays the same. So it'll be that. And for IC is 3.7 amps. And notice how it's a sine. So that means you either add or subtract 90, and since it's a negative, so you subtract 90 from that degree. So 125 subtract 90 degree is 215, negative 215 amps. And notice how both of them have different frequencies. That means we need to solve this problem using superposition. So for superposition, you basically turn off one source and then solve for your desired variable. So as you can see right here, we turn off ICT first, and then so what we need to do first, since we're using different frequencies, we need to do the solve the impedance of the components with that frequencies. For ZC, for the formula for impedance or capacitor is negative J over WC. So J is the imaginary, W is the frequency, C is the capacitance value. And for impedance of inductors is JWL, and J is the imaginary number, W is a frequency, L is a inductance value. So let's do it a little quick. Negative J, and then it's as you can see, it's a 230 radians per second times 1.3 millifarad. It gives us negative J 0.3.3445 ohms. So for the units of impedance, it's ohms. And then for the R inductance, 230 radians per second times 330 millihenries gives us J 75.9 ohms. And for the second inductors, J 230 18 millihenries gives us J 4.14 ohms. So that's it. And we basically need to solve for VAB right here, like the voltage in between that terminals right here. But what we can do is we can solve with the simplest way to solve this using no voltage. Let's look at the circuit below. So for no voltage, remember to always label your node. So right here, and then the other one, make it green to indicate my ground. So that's my ground. And I'll name the variable VAB. So let's start doing the no voltage. So let's start with the dependent source over there. So VAB. Oh, one thing for superposition, when you turn off the sources, right? For current source, it becomes an open circuit, and for the voltage source, it becomes short circuit. So let's see, VAB plus, since notice how the negative is like the is the up for the passive sign convention. That means it should be a positive for our no voltage, and then that capacitors as our resistance on the below. And the next one is a VAB over 6.8 ohms. Next one is VAB over negative J.3.345 ohms. And then notice how there's a current source that's directly going at that node right here. That means we can just write the current source over here. Oh, forgot the current. And then set it equal to 0. And then that will give us BAB equals 2.419, and the angle is 3.476. So if you want to convert your insert into time domain, always make sure it's in polar form at first, and then after that you can use that the voltage right here, and then in the angles into insert it right here. And remember, you need to use your frequencies as well. So that's the time domain for VAB. And then let's look at the second source. Since it has a different frequency, right? The frequency was a 290s, and let's solve it real quick. Gives us negative J.22525 ohms. And then the other one, 290. 330 millihenries gives us J 95.9 ohms. C 10 millihenries gives us J 5.22 ohms. Okay, now we got the impedance for all the components, and let's solve it with no voltage as well for VAC at that terminals. So let's label my nodes. Green is my ground, and I'll use VAC as my variable right here. Alright, so let's start with the same dependent source real quick. So VAC plus 3.3 AC over 5.23 ohms plus the VAC over 6.8 ohms, and then VAC over negative J 2.3 0.6525 ohms. And notice how the current right here is actually flowing into the node. That means it would be a negative. So it's negative 3. The angle is of negative 215 amps. And then set it equal to 0. Put it into a calculator. That should gives you VAC equals 5.64885, and the angle is 137.97 degrees. Alright, now we got VAB and VAC. So for problem like this with different frequencies, as you can see right here. Oh, and you convert it into time domain real quick. Sorry. See, VAC is, when convert it back to time domain, always make sure you use cosine. And to 290 radians per second, and T, subtract 137.97 degrees volts. Okay. For a problem like this with different frequencies, you basically just combine it together. So which gives you 2.419 cosine to 230 radians per second t plus 13.476 degree, and you plus, that's your VAB, and you plus the VAC, which is 5.6485 cosine 290 radian per second t, and then subtract 137.97 degrees. The unit is volt. And then that is your final answers right here. Alright, thank you for watching. Please give me a 5.